Hey guys, how are you doing? This is JSer, who is not good at algorithms. Today, let's continue our journey to LeetCode. This is 238, product of array, except itself. We're given an integer array, n is bigger than 1. Return an array bigger than 1, okay? Return an array output such that the output is equal to this product of all sum except itself. Like for this, the all sum is 24, so except this one, it's 24, and this two obviously is 1, 3, 4 is 12. It's guaranteed that the product of elements, any prefix or suffix of the array, fits. Okay, there's no overflow. Please solve it without division. Okay, actually we want the first idea came into my mind is division, because we except itself. Okay, we can calculate it, all the product with the big O n, and with another pass we can just do the division and get the result. So we should do it without division. Well, the naive version, I'll say division is one pass to get the all sum, all product, one pass to divide all product by each element, right? So this word needs to big O n and a space, no, constant. If we are forbidden with division. The naive one, we just do with one pass to loop through the element, and then in each pass we will loop through the other. But this will cost us n square, right? Space, this big O constant. This is a naive solution. For 1, we calculated 2, 3, 4, and for 2, we calculated 1, 3, 4. So now there is one duplicate calculation, right? For 3, 4 is used in 3, 2, and it is also used in 1, right? So what if we know so for 3 it was 4, right? 4 is used in all these 3 cases. So it's obvious that we could cache the result, right? From left and from right? For 1, for 3, there's a part of left and a part of right? So we could cache the product for 2 directions, from left and from right, and cache the product of specific index, right? So from left, the product from 0 to 0 is itself. Here is 3, and here is 6. So for each index, the product array except itself is the left part, and multiplied by the right. We could just get the cache the result of in this index with direction from left to right, and the product of this index from the cache of right to left, right? Cool. Let's cache the intermediate result. Well, we say the product at from left at comes product from right at, right? Well, we first loop it from left, we only need to know. We only need to. The last one is could be omitted. So this +1, right? Yeah, and then let product equals 1 and at each index. So product times by nums I, and we will cache the result product. And we will do the same for the right, right? This is I should be bigger than 0, should end at 1. Product, yeah. From right at I. Okay, this is at I. Okay, so last round we could get the real result, right? Product reset to 1 for let I equals 0, I smaller than num sub length. Oh, for the left, there's nothing there, so okay. It's there is a it might be 0, right? Yeah, okay. So for each index, we get a left and right from different cache, right? So product, oh, there's no product. This is a result array. Result I equals to product from left at I minus 1. Well, for 0, this does not exist, so we will well, if I is 0, then it's 1. Okay. If not is 1, there must be something in I minus 1. Cool. This times by, if I is the last one, then it's 1. Or this at I. And finally, we return the result. Well, this is pretty clear. Let's try to run the code. Oh, wrong answer. Never did it with one pass. Wow, this is it's weird. This is really weird. What we got? Oh, why are we going to? This is not right. Is this? We sum it up. We get the product, and then this we cache the product. I +1, man. Cool. Let's submit. Of course, we are faster, but not that fast, right? Why? Let's analyze these time and space. Time we use 3 round I, right? It's 3:03n, so it's linear time. Space we use 2 extras array, so it's linear time. But for time, it's not that good, or really. Is the problem that we're using the direct? What if we initialize it with Now start and end. Well, did this help? Oh yeah. Well, this makes difference? Really? No, it's doesn't matter. Okay. Could we improve it? It says, could you solve it with constant space complexity where you use linear space? The output does not count an extra space. Well, let's try to improve the space. You see, we are using two arrays to catch the result. And finally, there's another array, which is the result. And this is not counted as extra space because we need the result. So could we just merge these two arrays into one? Right? I think that's the approach we're gonna do. So I'll remove it. Remove the here. You see, if we get the product from left array, right? And then we're gonna calculate it from right? And actually, in this patch, the result could be get, right? Like we get 1, you already get 1, 2, 3. And then we could just, in a second round, we're calculating, we're get the first one is get empty, 4, right? Something like this. And we could just update it. This is used for once. We could update it to 12, something like this, and do it with one patch. And there's only one array, and there's will be only 2 for loops. So it will improve the time and space complexity. Cool. Let's try to do that. So actually, we could just use the result array. Okay, for the first patch, we product, let product equals 1. We calculate the product, okay, and set to result. Right? Wait a minute. For the first one, if we set the result, the index should be the previous one, right? The product means this product means the product including it. So actually, we should set result set I plus 1. Set, say this the product until this number is actually part of the result of this number, right? So yeah, so I from 0 to here, so it contributes to the result of this one to this one. Cool. And then we reset product to 1, and then traverse backward, and we get a product, and so the result of itself would be get the product. This product means write a product to I minus 1. This product means left product to I plus 1, right? Yeah. So result, this result actually is already the last number is already calculated, And so we need to calculate these results. So we only set the result I minus 1. Result 1 would be times by this product. And finally, we return the result. See if we're right. Let's review our code. Okay, so first one, we traverse 1, 2, 3, and calculate the product. And this first one is empty, and it would be 1, 2, 6, right? And then in a second pass, we will start with previous one, but the sum is over. The product will be 6. So 6 times 2. Wait a minute. So it's 6, right? 6 times 2 is 12. The 6 doesn't change. And here would be 12 times 1, so it's 12. Oh, it's not 6. This is 4, right? The sum is the product itself is 4. So 4 times 2 is 8. And then here it's 4. Wait a minute. 4 times 2, and then 12 times 1, and then 24 times 24. Well, here's a problem. It's undefined. We cannot multiply it, right? So what we do, we fill because the results are based on multiplication, we fill with 1, and this will do, right? Yeah, so I think it should work. Oh yeah, nice. Submit. You see, we are a little faster, but time complexity for this one doesn't change. It's only slightly, because it's still, we use 2 round for loop, so it's 2n. Still, it's the same as the previous one. But space, this result array is not counted as space complexity, so it's const time. Excuse me. Yeah, and that's all for this problem. From this problem, what we can learn is that for array of numbers or strings, there are so many cases that we could catch the result by like from left to right and the right to left, or starting at some index or ending at an index. So yeah, that's kind of like dynamic programming, caching, I don't know. So hope it helps. See you next time. Bye bye.